Hey everybody, welcome to AP Human Geography. All right, here we go. Today's lesson is going to be types of maps. As you're doing this, again, pay attention. This is going to be your notes on the content. You'll have a handout to go with this as well as some questions, but make sure you take your notes as we're going through. This PowerPoint has been posted in Google Classroom, but just make sure you're paying attention as we go through. So as we talk about these maps, first type of map we're going to get into is a reference map. All right, so again, when we talk about what reference maps are, you're going to have a reference to something. You're going to refer to something such as some type of a location. It could be places. It could be geographic features. So when we talk about these reference maps, it's going to obviously using the word in reference to a location or a reference to a feature. Is it a state? Is it a river? Is it the lakes? Is it the oceans? So that's what we get into when we start talking about this. So in your notes, you want to make sure you know this, that most of your reference maps that we're going to study all year are commonly going to be used as our physical and our political maps. So when we talk about physical maps as a reference map, those are going to be showing physical features, mountains, rivers, lakes, oceans, and so forth. So any type of your physical features is what we're going to talk about when we talk about a reference map there. Or it could be a political map. A political map, just like you watched in the video the other day, we talked about a political map. It's definitely going to be talking about political structure. So it's going to talk about cities, states, capitals. Now, if we're looking at some of these maps, the biggest thing when you look at a lot of maps is how do you differentiate the difference between a city and a state and even a country? Well, depending on here, if I look at this map right here, I can look on the screen, I see the word Florida is in all caps. So most of the time, if you're looking at a state level or a country level, your country or state is going to be in all capital letters. That's kind of a way to differentiate it. And then your cities obviously will be capitalized the first letter, and then so forth. And some of these, depending on what kind of map you're looking at, it can have a star or it can have a dot. It can be a larger dot or smaller dot if you're talking about size of population. But that's the biggest way to make sure we differentiate. And we want to answer those questions right when we're talking about tests and things like that, knowing the difference between a city, a state, and a country. If it's asking for something specific, to make sure we give the specific answer that it's looking for. The other one we're going to talk about is thematic maps. All right, so thematic maps, they have a common theme. Okay, so we're going to talk about some type of a map or a chart that's going to show a theme that is going to be connected with something that we're studying. All right, some type of specific geographic area, some type of data or content or topic that is going to be displayed here. So when we talk about thematic maps, we talk about population. You talk about religion. If you did your some reading in your textbook already, you have seen some of the maps in there about where population is distributed based on certain aspects and certain pieces of data. Well, that's a thematic map. These thematic maps are going to display this information, though, in different ways. And some of these are going to be more reasonable to use than others. You can't use every thematic map for every single topic. It just doesn't lend itself to that. So that's what we'll get into. Our first reference map that we talk about here is a reference map. We're talking about political maps, all right? So this is going to be a reference map, and this reference map is going to refer to the different congressional districts, and this is in the state of Tennessee. So again, it's got it broken up. I can see where it's outlined. All right, this is a political reference map, and we see, again, the congressional districts here. So political, again, we see some type of substance. This is going to be the congressional districts. You can do it county. You can do it for many different things, but some type of political structure. Here's a physical map, another reference map. Here we talk about physical maps. We talk about this is an elevation map, or another way to say this is a topographic map. So you're looking at the colors of and levels of elevation, which we'll talk about how that can also represent something else. But a physical, here we're focusing on what is the elevation, and for this one, the state of Idaho. Then here are our thematic maps. So we're taking notes, make sure we understand. Our thematic maps have a theme, and what is the theme that is going to be displayed here. So in your notes, you can kind of see the definition underneath. When we talk about a choropleth, all right, a choropleth map is going to be based on shading or coloring, in which we see a differentiation of data or area. It's going to be based on the shade of the color or how dark the color is or light the color is. So it could be shading, coloring, anything like that, where your map is differentiated based on color or shading, lighter and darker, is how we'll display a choropleth map. You've seen a lot of these, you've used a lot of these, and we'll practice with a lot of these throughout the year, but definitely practice them throughout the unit as well. A dot or dot density map, that is where a particular dot represents a certain value. One dot doesn't have to equal one of one value. So one dot doesn't represent one person necessarily, or one horse, or one store. All right, so the dots can also represent multiple values, but it's going to be an assigned quantity. So each dot is going to be specific to an area. It's kind of pinpointing an area, but also each dot can represent a certain quantity. So each dot could represent 100 horses, or 100 people, or 5 grocery stores. So depending on what that is, all right, each dot is going to represent something, but that's a dot density map. You'll put the dot in the location and it can represent a certain value, certain volume of density. Then we have isoline maps. All right, so isoline maps we see are going to use these continuous lines that are going to join pieces of information of the same value. So what we see here on this screen, we can see these are values. You look at temperatures. So here we're talking about the temperature in certain circles. And so if we look here at this circle under Columbus, we see it's about 63 degrees. Then you get outside of that, and anything inside of these lines in this circle, that would be indicative of 63 and a half. So depending on where the lines are connected, everything with inside of those lines, it may be a perfect circle like you see here with Columbus, or may not be a perfect circle like you see right outside of Columbus. As those values stay inside and you're inside of it, it's like coloring in the lines in the coloring book. As you're inside of there, that number keeps the same value. So coloring books are examples of isoline maps in a lot of ways, where everything inside of that line that has that number, that's that value. So that's what you'll kind of see. When we talk here, this would be talking about weather, in particular here up in Ohio. Another example that we see of both of these are isoline. A lot of the times you'll see it when it comes to weather. So we just did temperature. You can do rainfall. You can do, this is daily solar radiation. So you can talk about what these Langleys are in the areas. And so all these that are going to be up here from inside of this little purple line all the way down here, we're going to see that's going to be 500 Langleys. And then in between this line and this line, everything inside of that would be 450 Langleys. So you're talking about daily solar radiation there. So anything, that's what an isoline would look like. Here we see it acreage in potatoes. Now each dot didn't represent a potato. Each dot doesn't represent an acre of potatoes being planted. Each dot actually represents 40 acres here. So you have to take that into account when you're using this information, but that's an example. You've used dot density maps before. You've done them. You've seen these isoline maps before. You just may not have known the term just yet. Another example of a map is one that we kind of did already. You guys did your mental map. You did your mental map of the world. So this is going to be, what is your internal interpretation? What is your internal map of an area? And that is exactly where it shows up. That would essentially be your mental map. A couple other examples. These are your proportional symbol, all right, or graduated symbol maps. Now you can do proportional circles, proportional any shape, all right, proportional vector. So it all depends on whatever shape you decide to use. But whatever shape you use, the size of the shape is going to be proportional to the value that it's to represent. So in this regard, if we look up here in the Northeast Ohio region, the smaller circles represent a smaller population. The bigger circles mean more population. So again, this isn't the same as a dot density map, because dot density, you're just putting dots in certain areas. Whereas this one, you may have the symbol in an area, but it's going, the shape, the size of that shape is going to grow larger and smaller based on how things are set up for their population. Proportional symbol map, what we see here with the proportional symbol is you're going to notice that this proportional symbol, this vector, this flow vector map, as migration increased here with the trade routes, the slave routes out of Africa, again, those volumes are going to be represented. The thicker the arrow, the more volume. So that's your proportional symbol there as a flow vector. So you're showing the movement in an area, but you're also based on the size. If you look at these arrows here, the skinnier arrows are going to have smaller volume. The thicker arrows have larger volume. So that's proportional symbol. Two different ways to look at it. And again, you've seen these before, may not have known the term for them. So you've used a lot of these already. So here is another example of a flow map. We'll actually talk about this in Unit 2 when we get into refugees and migration. The skinnier the arrow, the less volume. The larger the arrow, the larger volume. Then you also look at destinations here. The bigger the circle, the more that was intaking refugees. The smaller the circle, the lower the value. So again, proportional symbol, whether it be a circle, a triangle, square, it doesn't matter what shape you use. Just know that as the proportion changes, so does the shape and the size of that shape. But we look here, another way we're going to see this, you're going to see a lot of this over the next month or two, but especially on election night, is cartograms. A cartogram we use a lot of the times when it comes to elections. So you're going to expand or shrink the size of an area based on the data it's to represent. So this is a map of the United States. Whether it looks like it or not, that's a little bit different. But as we look here, we see the size of it is going to be proportional to the population of the state here. In this case, it could be electoral votes. And this is an older map because some of these numbers have changed. So if we look here, we see the size of this. This is not based on volume of area. This is volume of, obviously, this is votes, because we know if we look up here with the Dakotas, we know that the Dakotas are pretty big, but as far as population and representation in Congress, this is going to be a lot smaller. While some of these states that are a little bit smaller may have a larger population, which makes them bigger in this map. So that is a cartogram. A lot of the times you'll also see this with population, like here. So we look at this one, and this distorts the shape of areas based on the data. And the data here is about world population. So just by looking at this, the size of the country is equivalent to the proportion of population it has of the world. So here we see China is the largest here. Charted is extremely large to begin with, but based on the population, China is going to be the largest one here, and then India second behind. But if I look at the size of these, there's another country that's going to be the third largest. All right, and so that's what we would see, and now you can see the United States here. So when you start to see some of these other countries, you can see Africa looks a little distorted here for sure. South America for sure. This one not as much with the United States, but Canada is definitely distorted. And you see it out here with Japan, all right, much larger than it would normally be. But that's what a cartogram shows, all right? What a cartogram goes here, again, it expands it or shrinks it based on what data is representing, all right? And this one you'll look at a lot more in Unit 2 when we get into the population unit. So just a little practice here. I want you to think out loud, think about what kind of map this would be, all right? What kind of a thematic map are we representing here? So in your head, just be thinking, be ready to answer that if that's a quiz question. And there you go. This one would be a proportional symbol, all right? So the size of the circle here represented the acres of wetland. So what we see here is, again, proportional symbol. All right, the circle got gradually larger and gradually smaller based on the value. And what kind of thematic map would we see here? All right, a thematic map here. Again, what we've seen is a little bit of a shrinking or even increasing in the size of certain areas. So what kind of a map would we have here? Yes, that's exactly what we would see. All right, so we're going to see a cartogram. Remember, it's going to shrink or expand the size of an area based on the data it's representing, and this data was the 2008 electoral votes. All right, so if we look, look, the largest physical state in the United States is not California. All right, the largest physical state is not California, but on this map, it makes it look like it is. Well, it's because of the population. That's why it's so distorted, so large. The largest physical state in the United States is actually Alaska. But Alaska here looks just as big as, actually, Alaska here, if we come back over here, it's smaller than Rhode Island, and it's the same size as Delaware. But that's because it's a cartogram. All right, just another example of a cartogram. All right, what we see here in the Electoral College from another election. And this is where we tend to see them a lot when it comes to elections and sometimes population. All right, here. All right, what we're looking at here is, again, the number of males per 100 females. All right, so that's the data it's showing. But what kind of a thematic map do we have here? All right, so what we see here is we notice a difference in the shaded areas and the colors represent a different volume. All right, what kind of a map would this be? It would be a choropleth. All right, it's a choropleth because of it's shaded. All right, so the shading area is going to be based on a certain value versus males versus females here. What kind of a map do we have here? And this one's a little different. We kind of talked about it, not directly. We related it to proportional symbol. It's going to be harder to tell because it's just an arrow, but this would be a flow vector map. So it's not proportional symbol in the fact that the arrow got bigger, but it's a flow vector. It's going to show you the movement All right, this is the movement from Lauderdale to Carroll. As we start talking about these things, and we'll get into that stuff a little bit more, but that would be a flow vector map. So that's it for today and this lesson. Go ahead and make sure you've answered all your questions and submitted it. I'll see you next time.